This video I have explained the algebra problems for TS, EAM, CET. I usually prefer making videos in Hindi, but since I'm making this for Telangana state and Andhra, now that Andhra is a separate state, and so I have preferred to keep this video in English. Okay, in this exam, engineering entrance exam, there are 80 questions for maths, and out of 80 questions 19 are algebra, so it's a very big weightage for algebra. So if you have covered algebra sufficiently, you will get like 25% marks from this topic itself. So when I compare the difficulty level with IIT JEE, it's much easier because the questions that are asked are straightforward, and if you remember the formula, the theorems, etc., you can complete the whole paper easily. So let us just start with the first paper that I have taken here. It was September 9 shift 1, and I have done the 19 problems of algebra. So let us just start. So first problem is match the following: range of secant inverse of 1 plus cos square x, and this here is the greatest function. uh, we all know what greatest function is, right? So greatest function of 0.5 is 0, greatest function of 1.1 is 1, and greatest function of minus 0.5, now this is a tricky one, this is minus 1. Everybody has the background for this function, so it shouldn't be a problem for us. So let us just start solving the problem. So over here, range of secant inverse of greatest function of 1 plus cos square x. So I'll first look at cos x. We know that cosine function lies between minus 1 to plus 1, and both values are included, minus 1 as well as plus 1. So what will be the value of cos square x? The values between 0 and minus 1, when you take a square of it, they will also become positive, and they will also lie between 0 and 1. So this will be cos square x, range of cos square x. I mean the value of cos square x for all the values that you might put in here. You will get a value between 0 and 1. So what will be 1 plus cos square x? Just add 1 to both of them. 0 plus 1 is 1, and 1 plus 1 is 2. Now when you apply a greatest integer function to this, what values will you get? You have all the values between 1 and 2. 1 and 2 are both included. Greatest integer of 1 is 1. Greatest integer of 1.1 is also 1. 1.99 is also 1. But greatest integer of 2 is 2. So the values that you will get are either 1 or 2. So what will be the range of this function? So this can only take either a value of 1 or 2. So the range will be secant inverse 1 and secant inverse 2. Now which is secant inverse 1? This one, fifth one. So A is 5. So A is 5. Now I only want to look at either B, C, D, one of these three. I don't want to do all A, B, C and D if just solving two of them solves my purpose. So I want to look at maybe C. So I have been given f of x plus y is equals to fx plus fy. It's very common problem. That's why I've chosen this. I already know the answer. Let us tell you how to solve this. F of x plus y is fx plus fy. Put y is equal to 0. You will get f of x plus 0 is equal to fx plus f of 0. Now x plus 0 is again x. So f of x equals to f of x plus f of 0. So your f0 is what? 0. f0 is 0. Now again put y equals to minus x. What will you get this time? F of x, instead of y I have minus x. So f of x minus x is equals to f of x plus, instead of y I have minus x. So f of x plus f of minus x. Now x minus x is 0. So what you will have over here is f of x plus f of minus x equals to f of 0. Now we have already seen that f of 0 is 0. So I put 0 over here. So I will have f of x plus f of minus x is 0, or f of x equals to minus of f of minus x. Now we know that if you replace x by minus x, and if the function remains the same, then it's an even function f, and if the function is negative of the original function, then it's an odd function. So this right here is an odd function, f of minus x equals to minus fx. So since this is an odd function, so c goes to 1, so a is 5 and c is 1, so option A is correct. Now let us move to next problem. Again, a very straightforward question they have asked. What's the domain of this function? So let us not get too much into the details. We know that the domain of secant inverse of x is minus infinity to minus 1 and 1 to infinity. If you want me to show you how we got this, then please let me know in the comment section. I will do a separate video. Let's not waste much time in this video. And besides, when you go for this exam, you should remember the domains and the functions of domain and range of standard functions. Otherwise, a lot of time will be wasted. And in this exam, they don't want to test too much of your uh, skills on the go. They just want to know whether you can solve problems fast. So that's why they ask standard problems. And if you know the formulas, the standard theorems, the range, the domain of standard functions, you will solve your questions really quickly. So I know the domain of secant inverse of x is minus infinity to minus 1 and 1 to infinity. This is union over here. Minus 1 and 1 are included. These values are excluded. So I will just put 3x minus 4 instead of x. So 3x minus 4 belongs to minus infinity to 1 and 1 to infinity. I will just add 4. This will stay the same. Minus 1 becomes 3. 1 becomes 5. This stays the same. Now I divide by 3. So this will be the domain of this. Now I have this as well. Tangent hyperbolic inverse function. Domain of tangent hyperbolic function is also known to us is minus 1 to 1. Both values are excluded. That's why I've used a simple bracket over here. So x plus 3 by 5 belongs to minus 1 to 1. I just replace x by x plus 3 by 5 to find out the domain of this function. First I will have to multiply by 5. I've done this. Minus 1 becomes minus 5. 1 becomes 5. Now I will have to subtract 3 on both sides. So x will become minus 5 minus 3 becomes minus 8, and 5 minus 3 becomes 2. So minus 8 to 2. Now that there is a plus sign between these two functions, I will have to take intersection of these two. So minus 8 comma 2 intersection with this, which we have seen above. So what will be my domain? My domain will be this value. So option C is correct. Next is third question. M equals 9n square plus 54n plus 80, 9n square plus 45n plus 54, 9n square plus 36n plus 35. The greatest positive integers which divides them for all positive integers n is. So how I decided to solve this problem is by factorizing this. Factorization is a concept that is taught in class 8th and 9th. So this should be fairly easy for everyone. So what I've done here is I've used the concept of a square minus b square. So to complete the squares, I've added 1 and subtracted 1. So 80 becomes 81. So this will be key. This will become this is 3n whole square. This is 9 square. Then this is product of 2, 3n and 9. 3 into 9 is 27 times 2 is 54. So 9n square plus 54n plus 81 minus 1 square. Over here it's straightforward factorization. If I take 9 outside, I get n square plus 5n plus 6. So that will be n plus 2 into n plus 3. I will take back 3 again inside, and I will get 3n plus 6 into 3n plus 9. Over here I have done very simple a square minus b square again. I did 1 and subtracted 1. 35 becomes 36. 36 is 6 square, so I will get 3n plus 6 whole square over here. So a square minus b square, 6 plus 1 will become 7, 6 minus 1 will become 5. So factorization leads to this. I will reorganize it and I will get this. So what is this? 3n plus 5, 3n plus 6 plus 7 plus 8 plus 9 plus 10. So these are 6 consecutive numbers. And I know that the 6 consecutive numbers will always be divisible by the product of 1, 2, 3, 4, 5 and 6, which is 720. Hence, this is the correct answer. Next is question 4. If A is a 3 by 3 matrix and the matrix obtained by replacing the elements of A with their corresponding cofactors is this, then a possible value of determinant of A is this. So we know that if we take the transpose of the matrix in which the elements are replaced by their corresponding cofactors, we get adjoint of A. And we also know this formula, that the determinant of adjoint of A is equal to determinant of A raised to the power n minus 1, where n is the order of the matrix. Since it's a 3 by 3 matrix, hence n is 3. Adjoint of A determinant will be equal to the adjoint of cofactor matrix. Since we are only taking the transpose, so determinant will remain the same. So determinant of this matrix is what I have put in the value over here. It's very simple to calculate. It's 9. So determinant of A squared, since n is 3 and minus 1 is 2, is 9. So mod A will become 3 or minus 3. We have given the option of 3 over here, so this is the correct one. Now look at the next problem. If A is equal to this matrix, then A square inverse is, so you don't even have to think anything. Just take A square and then calculate the inverse of it. I have done the calculation here. A square is this, and if you take the inverse of it, you will end up with this matrix. So, but you know that the process of finding the inverse of a matrix is a big challenge. It takes like 3 to 4 minutes at least. So if you take chances, try your luck, and multiply A square with A square. So if you multiply this matrix with itself, you will get I. If you are able to think this, then you don't even have to compute the matrix. You will see that if I multiply A square with itself, I am ending up with the identity matrix, which we all know is this. So in that case, you will know that the A square inverse is nothing but A square itself. Just remember to multiply A square with itself, and if you end up with this matrix, you know that the inverse is this matrix itself. It's an invertible matrix, and the inverse is the matrix itself. Okay, so next problem. The equations x plus y plus z equals to 3, x plus 2y plus 2z equals 6, and x plus ay plus 3z equals to b. They have no solution, infinite solution, unique solution. So that's very easy problem. What I have done is just considered this as 1, this as 2, and this as 3. I have eliminated x from these three equations, and I am left with this. Y plus z equals to 3, and a minus 1y plus 2z equals to b minus 3. Now from this, I want to know if I have unique solution or no solution or infinitely many solutions. So I have to compare the coefficients of y and z. So over here I have 2, so I have changed this to this so that the comparison is easy. So I multiplied this equation by 2 on both sides, so I get what? 2y plus 2z equals to 6, and I have a minus 1y plus 2z equals to b minus 3. Now if a minus 1 is not equal to 2, then these equations will intersect with each other and I will have a unique solution. So for a unique solution, a minus 1 is not equal to 2 or a is not equal to 3, I will end up with a unique solution. Unique solution when a is not equal to 3. So C is the correct answer, but we also want to see what are the conditions for infinitely many solutions or no solution. So no solution will happen when a minus 1 equal to 2. A minus 1 equal to 2. Then these two lines are parallel to each other, but whether they are overlapping or not overlapping will determine whether we have infinitely many solutions or no solution. They will overlap when b minus 3 is equal to 6, then they will overlap and you will have infinite solutions. So overlapping lines, I have given the condition here, a is equal to 3 and b is equals to 9. And if b minus 3 is not equal to 6, then you will have no solution. A equals to 3 and b is equals to not equal to 9, then no solution. We know that the correct answer is C. Now next problem is complex number problem. Z belongs to C. C is a complex number. Iota equals to square root of minus 1. A, B and C are real numbers which lie between the values 0 and 1, such that a square plus b square plus c square is 1 and b plus iota c is equals to 1 plus a into z. So z is given to us, which is b plus iota c by 1 plus a. They have asked me what is the value of this thing, 1 plus iota z by 1 minus iota z. So what will I do? I'll just put the value of z over here and try to solve by taking LCM. So I took the LCM and I end up with these. Open up the bracket, iota square is minus 1, so minus minus becomes plus. Similarly over here, plus and minus become minus. So I end up with this expression. Now look at the options that are given to us. Either it's 1 plus a or 1 minus c in the denominator. So in the denominator they have only real values. But what I have right now, I have an iota in the denominator. I want to get rid of this. How do I get rid of this? I will do a minus b into a plus b is equals to a square minus b square. So if I have minus iota in the denominator, I will multiply it with an expression which has plus iota b, and it will be easy for me to solve a minus b into a plus b. So what I have done is 1 plus a plus c as a and minus iota b as b, just to let you know how I have done it. So 1 plus a plus c minus iota b is what I have, and I have multiplied it with 1 plus a plus c plus iota b. So this will become this whole a square and this whole b square, and minus iota square will become plus 1. Okay, and since I have multiplied with this expression in the denominator, I will have to do the same in the numerator as well, which I have done. Once I have simplified this expression, I will be left with these minus b square minus c square in the numerator, and a square plus c square plus b square in the denominator. You don't have to be scared of it, because a square plus b square plus c square is 1, which is given to us. So we will get rid of all these three, and I will get rid of this. So minus b square minus c square will be a square minus 1. So 1 and 1 will also get cancelled, and a square will become 2a square, which I have got over here. Now I have to do is just factorize. So take 2 common here, you will be left with a plus iota b. Take 2a common here, you will be left with a plus iota b. Now take a plus iota b common, you will be left with 2 plus 2a. Just take 2 outside as well. So a plus iota b into 1 plus a into 2 is the numerator. And in the denominator I have done similar work, and I am left with 2 into 1 plus a into 1 plus c. 1 plus a and 2 will be cancelled. So you'll be left with a plus iota b by 1 plus c. So option A is correct. So again, another straightforward and easy problem. And you know, this is a very popular question. If you have done some practice for IIT JEE or other engineering exams, it's very straightforward, asked many times. So if you have done practice, you can just straight up mark A. Don't even need to solve, because it's just that popular question. Now next problem on complex number. Z is x plus iota y, and real part of z minus 1 by z minus iota is 2. What is the locus of point P? So just put z equals to x plus iota y. Again, very simple and very straightforward problem. Z minus 1 by z minus iota is 2. Put x plus iota y in place of z. Now take iota common, y minus 1. Again, in the denominator I have iota, I need to get rid of it. So a plus b, I will multiply it with what? A minus b. Just like I did in the last problem, I will do it over here. And this will become a square minus b square, iota square is minus 1. So I will be left with x square plus y minus 1 whole square in the denominator. This one. In the numerator, I will have to multiply these two expressions and see what I end up with. So what I end up with is over here, x square minus x plus y square minus y by x square plus y minus 1 whole square. This will be the real part, and imaginary I am not considering, because I am only concerned with the real part of this number, which is given to me as 2. So this is 2. So just take this over here, multiplied by 2, and this bring this whole expression on the left. You are left with what? X square plus y square plus 3y plus 2 is equals to 0. And we always know that if the coefficients of x square and y square are the same sign and same size, so both are +1, so this is usually the equation of a circle. Once we complete the squares, we are absolutely sure that it's a square, and we have 1 by 2 over here, which is square of 1 by root 2. So radius is 1 by root 2, and the center is what? Negative of this and negative of this, which is minus 1 by 2 and minus 3 by 2. So option B is correct. Is it though? I think I made a mistake over here. Next problem. If omega is the cube root of unity, then what is this plus this? We know that when omega is cube root of unity, that omega cube equals to 1, and 1 plus omega square equals to 0. Very straightforward problem. 1 plus omega square is what? Minus omega. Minus omega minus omega minus 2 omega minus 2 raised to the power 6 is equal to 2 raised to the power 6, which is 64. Similarly over here, 1 plus omega is what? Minus omega square. Minus omega square and minus omega square makes 2 minus 2 omega square. So again, minus 2 raised to the power 6 is 64. We are left with omega raised to the power 6 and omega raised to the power 12. Omega cube is 1, so omega raised to the power 6 is also 1. Omega raised to the power 12 is also 1. 64 plus 64, 128. Easy. Now look at question 10. If e to the power iota x is a solution of the equation z raised to the power 1 plus z1 p1 zn minus 1 plus p2 zn minus 2 plus dot 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 plus pn equals to 0, where pi are real and I equals to 1 to n, then what is the value of this expression? If I substitute e to the power iota x right away in this, we know that e to the power iota x can be written as cos x plus iota sine x. So e to the power iota nx will become cos nx plus iota sine nx. So I will have p1 multiplied with sine raised to the power sine of n minus 1x. But in the problem, he has asked for p1 sine x. So I want z raised to the power 1 over here instead of z raised to the power n minus 1. So what I can do is divide both sides by z raised to the power n, or multiply with z raised to the power minus n, which I have done here. So when you multiply this with z raised to the power minus 1, you will get what? 1. This will become z raised to the power minus 1, this will become z raised to the power minus 2, minus 3, dot dot dot, plus pn will become pn z raised to the power minus n. Now I can substitute e to the power iota x. You will be wondering, I have minus sign over here. I will not get sine n minus 1x. So what? Sine of minus n minus 1x is minus sine n minus 1x. We will just take the negative sign outside. And that is exactly what I have done. E to the power minus iota x is cos of minus x plus iota sine of minus x. Similarly over here and over here. Take the minus sign outside. Cos of minus is cos because it's an even function, and this is an odd function, we know that. So these will just stay the same and they will have negative sign outside. Now we separate the real and imaginary terms. So 1 plus p1 cos x plus p2 cos 2x on one side and iota terms on another side. Take iota common. So this is the imaginary part. Imaginary part is not over here. So this is equal to 0. But what is asked from us, he has added plus 1 over here. So I will add 1 to this. So this will become 0 plus 1, which is 1. Hence my option C is correct. Question 11. Now we have moved to quadratic equations and theory of equations, etc. etc. 3x square minus 16x plus 4 is greater than minus 16 is satisfied for some values of real x in 0 to 10 by 3. Let us look at this. Is greater than minus 16, so I bring 16 over here, so this becomes 20. Now I just have to factorize it. You know, we can factorize it, right? So 3 times 20 is 60, and 10 and 6 is 60, and 10 plus 6 is 16, so easy. So that is how I have factorized it. Minus 6 minus 10, taken 3x common, so I will be left with x minus 2. You take minus 10 common from here, you will be left with x minus 2. Take x minus 2 common, you will be left with 3x minus 10. So either x is less than 2 or x is greater than 10 by 3. This is wavy curve method. So this is satisfied for some values of x in 0 to 10 by 3. Yeah, answer is correct. Now look at the reason R. It says ax square plus bx plus c, and a will have the same sign for some real values of x when b square minus 4ac is greater than 0. You know that when b square minus 4ac is greater than 0, then ax square plus bx plus c equals to 0 will have what? Real roots. That is, if this is ax square plus bx plus c and b square minus 4ac is greater than 0, then it will have real roots. That means it will have to intersect x-axis. Okay, and if this is equal to 0, it will just touch at one point like this. It will be like this. Now since it's greater than 0, it will intersect in 2 points if a is greater than 0, and if it's less than 0, then this curve will just be inverted. So as can be seen that this curve and a share the sign. They have the same sign for some values of x. In this, a is greater than 0 and curve is greater than 0 for all these values and all these values. So they have the similar sign for some values of x, and over here if a is less than 0, then this curve is also less than 0 for all these values of x and all these values of x. So R is also true, but it says about the whole x-axis. You know, it doesn't say about a particular interval. Hence, I don't think it's the correct explanation. But in the answer key, it's given for this. I don't know, there might be some mistake in the problem or in the solution. Now, let us look at question 12. If the roots of the quadratic equation are imaginary, you know that imaginary roots, that means b square minus 4ac is less than 0. That's the one condition. Then for all real values of x, the minimum value of this expression. For calculating the minimum value of an expression, what you can do is take the derivative, equate the derivative to 0, use the value of x, put the value of x over here, and you will get the minimum value. Or you can do what I have done, just complete the squares. So I have done it, and I have left with this expression. So what will be the minimum value of this expression? Just minus b square, because squares are always positive for real numbers. And the minimum value of this square will always be just 0. If x equals to minus b by a, this will become minus b plus b, which is 0. 0 square is 0. So 0 minus b square is minus b square. So that will be the minimum value. If I use any other value, then this will become positive and the value will be greater than minus b square. So the minimum value is minus b square. And we know that the roots of this equation are imaginary. So b square minus 4ac is less than 0, or b square is less than 4ac, or minus b square is greater than minus 4ac. The less sign becomes greater sign because I have multiplied both sides with the negative sign. Hence the minimum value is minus b square or greater than minus 4ac. So option C is correct. Now question 13. If alpha, beta, gamma are roots of this equation and fx equals to this, then sigma alpha square beta plus sigma alpha 4 is equal to what? Now this is a very lengthy problem, but also very simple problem. If you know the expressions for these sigma alpha square beta and sigma alpha 4 already, then this question will take you like 30 seconds. If you don't know, then you will have to derive the value of these sigmas, and it will eat up 10 minutes of your time. So if you know the formula, good. If you don't know the formula, skip this problem. We have all the time over here because we are solving it offline. We are not in the exam hall, so we can calculate. I have done this calculation over here, sigma alpha square beta. So I will multiply alpha plus beta plus gamma with this. I will expand the expression. I will combine. I will do this. I will do that. I will get the value of sigma alpha square beta. And we know that alpha plus beta plus gamma is minus b by a. B is 0, a is 1. So this is 0. Alpha beta plus beta gamma plus gamma alpha is c by a. C is what? P. A is 1. So this value will be p. And alpha beta gamma minus b by a, c by a minus d by a. D is q, so minus d is minus q, divided by 1 is minus q. So minus into minus is plus, so this value is 3q. Similarly, you will have to do with alpha 4. This will be a even bigger challenge. So what I will do is I will take the square of alpha p plus beta plus gamma. We know that the square of this is what? A square, b square, c square, 2ac, 2a, 2bc, 2ac. Now alpha plus beta plus gamma is 0, so I will just put 0 over here. So alpha square plus beta square plus gamma square plus 2 alpha beta plus beta gamma plus gamma alpha. We know this value as well, which is equal to what? P. So we can substitute it. We will get this alpha square plus beta square plus gamma square equals to 2p. Now square it again. We'll get alpha 4 plus beta 4 plus gamma 4 plus again 2ac, 2bc, 2ca. 2p whole square is what? 4p square. Now this is another expression whose value we don't know, so we will have to compute. So I need this value. Consider this expression alpha beta plus beta gamma plus alpha gamma equals to p. From here I will have to square this term to calculate the value of this. So when I square it, I get a square, b square, c square, 2ac, 2bc, 2ca again. So this is equals to p square minus, from all of these expressions you can take alpha beta gamma common. So you will get p square minus 2 alpha beta gamma into alpha plus beta plus gamma. We know that alpha plus beta plus gamma is 0, so this whole expression is 0. So we are left with what? P square. So alpha 4 plus beta 4 plus gamma square is what? 4p square minus 2 of this. And I know the value of this expression is p square. So minus 2p square. So this will be 4p square minus 2p square or 2p square. So sigma alpha 4 is 2p square. I know that sigma alpha square beta is 3q. So sigma alpha square beta plus sigma alpha 4 is 2p square plus 3q. Like I already told you, if you don't remember the formula, you will waste 5 to 10 minutes, and which is undesirable in this exam. So if you don't know the formula, do not attempt this problem. I have derived it because I have time over here. I'm not writing an exam. Option A is incorrect, option B is correct, because what? Fx is also given, fx is given. So put f of 1 because the option mentions f of 1. F of 1 will be what? X is 1 over here. So 3p square plus p square plus 3q. So 4p square plus 3q. Put x is minus 1. 3p square minus p square is 2p square plus 3q. We know that it's 2p square plus 3q. We have already computed. So option B is correct. Now a similar kind of problem over here. If alpha, beta, gamma roots of this equation, then this. So like I said, it's better if you remember these formula. We have time, so we can compute the value. We can expand the expression. You will get this. Again, alpha plus beta plus gamma into alpha beta, beta gamma, gamma alpha. I multiply these expressions. I will end up with this plus 3 alpha beta. Just take 3 alpha beta over here. And we know that alpha plus beta plus gamma is what? Minus b by a. B is what? A. So minus b will be what? Minus a divided by 1 is minus a. Don't get confused, okay? This will be minus b and this will be minus c. Alpha beta gamma. Alpha beta gamma. So alpha plus beta plus gamma is minus a, and then minus b, and then minus c. You know that minus b by a, c by a, and minus d by a are the values that I'm talking about. So in this case, b is what? A. So minus b will become minus a, and a is 1. So this will be minus a, and c by a will be what? Minus b by a, c by a, c is minus b, so minus b, and d by a, minus d by a, sorry. So d is what? C. So this will be minus c by 1 or minus c over here. So AB plus 3C, option D is correct. So this is very straightforward problem, but the only difficulty here is remembering the formula. Please remember the formula. Now question 15. If the number of all possible permutations of the letter of mathematics in which the repeated letters are not together is 982 into x, then x is what? We already know that 982 is given, then in the solution 982 must come, and x we will have to compute. So mathematics, you can write it down. You will get 2m, 2a, 2t, 1h, 1e, 1i, 1c, 1s. So total 11 letters, out of which 2 are m, 2 are a, 2 are t. So total permutations is 11 factorial by 2 factorial, 2 factorial, 2 factorial. 2 factorial is 2, so this will be 8. Total permutations will be 11 factorial by 8. But he's saying I want to know about the permutations in which the repeated letters are not together. I know the total permutations, and I do know the permutations in which they are always together. So I will just subtract those two and I will get my solution. So if 2m, 2a and 2t are taken as together, you will get how many letters? 8 letters, right? So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1 of this 6, 1 again 7, and 1. So 2t I am considering as 1, 2a I am considering as 2, 2m I am considering as 1. So total permutations will be what? 8 factorial. So my answer is what? 11 factorial by 8 minus 8 factorial. Now this is equal to 982x. So what I have done is I have expanded 11 factorial. I have written it as 11 into 10 into 9 into 8. Now it's divided by 8, so 8 is disappeared. And 8 factorial I have written as 8 into 7 factorial. And then I have taken 7 factorial common, okay, which I have done here. So I am left with 7 factorial into 990 minus 8, which is 982. The, the problem says the permutations is 982x. So x is what? X is 7 factorial. 7 factorial is 5040. So this is the answer. Now this is circular permutations. Next problem. There are 10 if you look at the exam, you will always find there is one problem on circular permutation, one on straight line permutation. So the problems are always of the same nature. If you solve one question paper, you will know what kind of problems they ask. Hence it's important to revise. If you revise questions, you will always get good marks in this exam. So this guy says there are 10 red and 5 yellow roses of different sizes. If X is the number of garlands that can be formed with all these flowers so that no two yellow roses come together, and Y is the number of garlands formed with all these flowers so that all the red rows come together, then what is this value? X minus Y times 2 divided by 10 factorial. So we know 10 factorial will figure in the solution. First X. X is what? The number of garlands that can be formed so that no two yellow roses come together. So what will I do is first I will put the 10 roses in a garland. We know that n flowers can be used to make a garland in n minus 1 factorial by 2 ways. So this can be done in what? N factorial by 2 ways. Now I have 5 yellow flowers and they should not come together. Since I have 10 red roses in a circle, I have 10 spots between them, and I can put each yellow flower in one of the spot. First yellow flower will have 10 options, next will have 9 options because it cannot come in the same spot in which one flower has already been put. Next will have 8 options, fourth will have 7 options, fifth will have 6 options. So total options will be 10 into 9 into 8 into 7 into 6. And the 10 red roses can be arranged in a garland in 9 factorial by 2 ways. So what will be the value of x? X is half into 9 factorial into this. What I have done is multiply it with 5 factorial and divide by 5 factorial. So the numerator will become 10 factorial. Why I have done this? Because this guy has asked 10 factorial here. So I have made sure I have 10 factorial over here. Now what is y? Y is the number of garlands in which all the red rows come together. So I'll just first put the 5 yellow flowers in a garland. We know that 5 yellow flowers can be put in a garland in n minus 1 factorial by 2 ways. So that's 4 factorial by 2 ways. Now I have 10 red roses and I want all the 10 roses to be together. And how many options do I have for these 10 roses? I have 5 yellow roses in a garland, so I have 5 spots open. I can put the 10 red roses in any of the spots available to me, so that can be done in 5 ways. So 4 factorial by 2 into 5 ways. But all the 10 red roses which are put as together, they are all different. So all these 10 red roses can be rearranged among themselves in how many ways? 10 factorial ways. So this is why 4 factorial by 2 into 10 factorial into 5. X minus y will be what? Half of 9 factorial into 10 factorial by 5 factorial minus half of 4 factorial into 10 factorial into 5. Take 10 factorial by 2 common. Why have I done this? Because this guy is asking me 2 into x minus 1 by 10 factorial. So I took 10 factorial by 2 outside. I will take them on the left. So I will be getting 2 into x minus 1 by 10 factorial. And what am I left with over here? 9 factorial by 5 factorial minus 5 into 4 factorial. 5 into 4 factorial is 5 factorial. So the option A is correct. Now, what do I have over here? It's an infinite series. Y is equals to 3 by 4 plus 3 into 5 by 4 into 8 plus 3 into 5 into 7 by 4 into 8 into 12. Again, a very straightforward problem of expansion where n is negative or a fraction, and we know the condition of x. Condition on x is mod of x is less than 1. So the expansion is always this: 1 plus x raised to power n is 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 by n minus 2 divided by 3 factorial x cube. I don't have 1 in my original series, so I will add 1 to y. So y plus 1 will be this. Now nx will be 3 by 4 and n into n minus 1 by 2 factorial will be into x square will be this. 3 into 5 by 4 into 8. You will have to solve these two equations and you will get this: x is minus half and n is minus 3 by 2. I'll just put x over here and n over here, and y plus 1 will be x is minus half, 1 minus 1 by half, n is minus 3 by 2, minus 3 by 2. Half raised to the power minus 3 by 2 or 2 raised to the power 3 by 2. Take minus 1 over there and then we can square it again. I have squared because in the options I have y square. So y square is equals to what? A square plus b square minus 2ab, because minus sign is over here. 1 minus 1 square is 1. 2 raised to power 3 by 2 square will be 2 cube, which is 8. So my 9 minus 2 into 2 raised to the power 3 by 2. I want to get rid of this because in the solution I don't have any 2 raised to the power 3 by 2. 2 raised to the power 3 by 2 is what? Y plus 1. So I put y plus 1 over here. Y square is equals to 9 minus 2 into y plus 1. So y square plus 2y minus 7 equals to 0, which is one of the given options. So done. Now question 18. If the coefficient of x raised to the power 13 in the expansion of this is a into 2 raised to the power 10, then a is equals to what? So this is very similar question to the above. 1 plus x square, we know that this is a plus b whole square. So 1 square plus x square plus 2x. 1 square plus x square plus 2x. And this expansion is what? Since this is in the denominator, I will take it into the numerator. I will get what? 1 minus 2x raised to the power minus 3. As I have this series over here, 1 plus x raised to the power n, 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 by 3 factorial x cube plus dot 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 dot. I will use that to expand this, and I will find out the terms of x raised to the power 11, 12 and 13, because I have 1 over here, x square over here and 2x over here. So 1 will be multiplied with the term of x raised to the power 13, okay, and x raised to the power 11 term will also get multiplied with x raised to power 2. So I will again end up with x raised to the power 13, and the x raised to the power 12 factor in this one will get multiplied by 2x, and I will again get x raised to the power 13. You just have to add those three and you will get your x raised to the power 13 coefficient, which I have done here. I have expanded this. Now we'll consider the terms containing 11, 12 and 13. I am not a fool because they have asked me only x raised to the power 13. So I am not stupid, so I am not going to compute the coefficient of x, x square, x3, x4, x5, x10. Those are useless to me. Just compute these three. I have done it over here, x11, x12, x13, and since the power is negative and this sign is also here is negative, so all the terms will be positive, so need not worry about the sign over here, all are positive. Do you know that why am I saying this? Because 1 by 1 minus x is what? 1 plus x square plus x cube plus dot dot dot, all the terms are positive. So because this is what 1 minus x raised to the power minus 1. So the power is negative and coefficient of x is negative, hence all the terms will be positive. So I'm not worried about the sign here, just straight up add them. And just remember that when you look at the x raised to the power 12 coefficient, multiply it with 2 because we have 2x over here, not just 1x. Like we have 1x square and 1 here, but we have 2x, so multiply it with 2. Add all of them, you will get 1724. A very straightforward problem. Just simple calculations. Question 19. If the partial fraction decomposition of this is equal to this, then a minus b plus c is what? So we do this in definite integrals. We decompose this into fractions so that the integration is easier. This is a part of that. So what I will do is take the LCM of x plus 2 x square plus x plus 1. So a will be multiplied with this, b will be multiplied with this, c will be multiplied with this, and then we start putting the values of x equal to 0, 1, minus 1. I have done all of this, so I am left with equations 3a plus c is 5, and a plus 2b plus c is 1, and minus 1 for my I will get a plus b plus c is 2. Solve them. It's a straightforward problem, no time needs to be wasted. It's a 30-second problem. So we are done with algebra. It's 19 out of 80 questions, and very simple and straightforward problems are asked. If you revise well, you will score well in this exam. So see you in the next video, which will be on trigonometry. Thank you.